Hi, everyone. Welcome to the Bag Room. I'm Ryan Ballingy. It's great to have you here with us. Aki Yorihiro is back with us. He is the founder and chief technology officer for Newton and Newton Golf Shafts. You may know them as Saks Parente in the past. They've rebranded as Newton, and that's in part because of the killer shafts that they make. I have one in my driver. Aki helped me out get outfitted for one, and I've been loving it. So we wanted to come back on and talk about not only Newton shaft that I've been using, but also the expansion of the line. So, Aki, first, thanks for being here. Second, can you let folks know what you at Newton have been working on in the shaft world since we last spoke?
Wow. Well, thank you for having me on. We have been busy. We've been, off season since, October or so. The Newton Motion launch back in November 23, that's been extremely successful. But it's not to say that we stand still. So we keep improving the motion. And so even for the motion in 2025, I think we have made drastic tweaks and improvements. Last week, I was in Tucson for the Champions Tour, and that was the first week that I had the finalized 2025 motion. And they were flying absolutely crazy, crazy good. I got 4 new players in 2 days. And I think that shows that, when the performance is so great, they'll put it in play, and we're ecstatic. In addition to the motion, we are launching a fast motion, which is approximately 7 to 10 grams lighter than the motion. And that has been in development for a long time. We are doing our final tweaks. I've been testing it on the tour. There are 2 tour players, one LPG, one on the Champions Tour, that have been playing the Proto Fast. And we're very, very happy with the results. And so we will be launching that officially in the next, several weeks. So that's kind of where we are.
So on the fast shaft,
Yes.
what's the comparison range of the original Newton to that one in terms of the weight profile?
Right. So let's pick Velic or Ventus, right? So when we started with the Newton and the current day Newton, if you took an X shaft, it would be an equivalent to a 7X Ventus. I mean, it could be other manufacturers too, but anytime a manufacturer would say it's a 7X uncut, it's roughly 77 grams. And that's kind of the range that that Newton Motion is, maybe a couple grams lighter than that. And so the fast motion is really intended to be the 6X, if you were. So 6X in that particular shaft will be 66 grams uncut, I believe. And that's the gapping, that's the matching. I think those are the kind of the weight sequences that players are accustomed to. So we're trying to keep it kind of in line with that. So X, so our 6 will be in the 60s, the 5 will be also in the low 60s. Then you got the 4 and the 3 dots, that'll be in the 50s, right? And then the one will be like low 40s. So
Okay.
so that's kind of the sequence. So from 40 to high 60s would be the fast motion.
Have you found in trying to educate folks about Newton shafts that it's kind of hard for them to kind of place they know what shaft they like, maybe,
Mhm.
if they've been
Mhm.
fitted for something they like, but they don't know much about the specs of it because there's not that there's not standardization, there is in spec, but not in nomenclature.
That's right. That's right. And I run into that a lot because people ask me, how many grams is this shaft? And I try to be as simple as I can, but also be as precise as I can. So I would always say it is however many grams uncut,
Yeah.
however many grams uncut. Because obviously it depends on the length you're playing. I mean, I would say 80% of golfers, if they see a 50 on their shaft, let's say it's an S50 or R50, they think it's a 50-gram shaft, like
Yeah.
50. But in reality, uncut, you're probably talking about 56, 57 grams. And so there is a little bit of education involved, and I think on our specs chart, we might do actual weight and also a weight category so that people can relate to either. It's
Yeah.
something that we think might be a good idea.
And do people? I mean, I know their weight's probably the first question that comes out of people's
Mhm.
mouths, but do they come to you asking about torque? I mean, are they trying to fit into a torque rating too? And do most people have a conception of what that scale looks like for golf shafts?
So definitely, there's people are curious about the tour, what they're playing, whether there are any trends, so on and so forth. And really, it's even, whether it's the PGA Tour, whether it's the Korn Ferry, the Champions or LPGA, they're kind of it just depends on the person, right? It just depends on the person. I think in LPGA, you definitely see lighter shafts. So I think
Sure, yeah,
the fast is definitely targeted. I'm going to expect that 80% of our players are going to be on the fast on that tour. But I will tell you on the Champions Tour, I still expect, 7 out of 10 players to play the motion rather than fast motion, because I think weight is, what people are used to, the sequencing, um, whether you want low torque or low torque, all these things come into play. And I think maybe in the last few years, there's been a really big push to go lighter.
yeah,
And I also think that it's not for everybody. So some people are coming back and saying, you know what, I've tried the light shaft. I'm kind of spraying it. So I think I'm going to go back to the original weight, if you were. I hear
and
that a lot.
how do the torque numbers compare between the motion and the fast motion? What do those numbers look like torque wise?
Yeah, so torque, they're going to be very low. Over the 25 motion, we will actually be coming under the 24 motion. And we'll be publishing those specs soon. We're very, very happy with, I mean, it's the design, it's the manufacturing process, even things like sanding, we've improved quite a bit, and so the torque has gone down. You can expect the fast motion to have slightly higher torque. So let's say, I mean, this is an example, but it's, again, it's to be determined. But let's say our 6 dot is 3.0 on the motion, and it might be a 3.2 or 3.3 on the fast. So it's pretty negligible, right?
Yeah,
Pretty small differences.
yeah. Most people aren't gonna see that too quickly on a launch monitor. They're certainly not gonna feel it too quickly
Right.
in terms of when they hit it. And then you talked about this just a second ago. Just the improvements that you're making in the manufacturing process.
Mhm.
One of and I always find this fascinating because we're talking about such small margins, right?
Yes.
So what does big improvement look like in sanding? What does big
Right.
improvement look like in manufacturing? And how does that translate to some metric, some percentage metric that you all at Newton are like, this is a big deal? How do
Sure.
you drive it? Like this is a big advance for us.
Yeah, exactly. So like we're nerd. I'm a nerd, right? I'm a golf nerd. And so you're right. What I think is huge, somebody else might think, oh, that's it, but just to kind of put things into perspective, from the time that a shaft is wrapped and baked, right, comes out of the oven, you take the wrapper off, and it's very rough, right? So then you're going to sand it so that it's paint ready. So that's that paint differential, or I'm sorry, the weight differential, the sanding differential. And so, let's say we were sanding, this is an example, but let's say we were sanding 4 grams last year on average from the time the shaft is born to when it goes into paint. We've reduced that to 2 grams or maybe a little bit less than 2 grams, so 1.8 to 2 grams, and that's over 46.5 inches.
Yeah.
So, I've improved it by a gram or possibly 2 grams. And again, that might not seem like a lot to people. To me, that's like, putting a spaceship on the moon. I mean, it's that different.
Well,
Okay.
against 4 grams, that's
Um,
50%.
Exactly. And what it allows us to do is, when you're sanding, you're taking material off, right? So you design a shaft and then you sand it. So you are trying to guess at the resulting performance after sanding. So the logic would follow that the less I sand, if I go minimal sanding, I'm keeping as much of the original design, the original taper, all of that intact, right? Almost untouched. And that's really the idea behind that. And it's crucial for the motion as it is for the fast motion. Fast motion, because we're taking 10 grams out of the shaft, we have to operate at a much higher precision level, and we don't have a lot of material to spare, right?
Yeah.
So those are like, and so that's kind of an example. So I don't know if that seemed like monumental to you, but to me,
Well, I
I'm
mean, if you put it in the
super
context
excited.
of, yeah, we shaved four off, we now shave two off,
Yeah,
that's a lot. I
yeah.
guess if you did the division of grams per inch, you went, well,
Mhm.
0.03, 0.04 grams per inch. I guess
Right.
that doesn't seem like such a big deal.
Right.
But, again, depends on the context, right? But
Right.
I think the more important point that you made is it gets closer to what we originally engineered
Right.
by taking 2 grams off as opposed to four, than
Right.
having to, and it'd be great if you could explain this,
Mhm.
what you had to do previously, knowing you're going to take closer to 4 grams off to get it to do what you wanted it to do in the first place.
Right, right, right. I think before we were doing just a little bit more, adding a little bit more fibers in the design because we
Mm-hmm.
knew we were going to get to a certain point. But, sanding is kind of a variable because, I mean, not to get too nerdy, but, when you start with a new paper, it takes off more.
Right,
And
right.
as you run through, let's say 20 shafts, it's going to take off less. And so there's this variability. And the way we cut our materials, it's a CNC. It's always the same. 100 out of 100, 1,000 out of 1,000. But
Yep.
sanding is necessarily slight. There's a slight variable
Yeah.
because of just even how the sandpaper reacts. So if we can do it less, then we have less of a variable. And if we can have less of a variable, we have more consistency across the board from shaft to shaft. And then same thing with the performance. Like I want to, we talk often about our elongated bend profile, and the profile is hugely important to us, and the performance of our shaft, and how it goes straight and how it bullets out. It's all about the profile, the bend profile, and again, improving the sanding process maintains our shaft profile. And so that's one of the things I've been looking for, like on the tour. And it's just been, I mean, I was almost in tears looking at these new shafts for 2025, being swung by pros, and they're just like going out, up, out, just bulleting out there, very, very straight. Um, it was, it's pretty exciting for us.
I'm going to get super nerdy with you here because I do find the sanding thing really fascinating. And that is, okay, you're using a certain grit, right? I mean, but the
Yeah.
distribution of that sanding, how do you try to make that as even as possible, or do you not try to make it even, and you're trying to create that bend profile with an awareness of where that bend happens within the weight of the shaft?
That's an excellent, I mean, that's one of those questions that I never hear. I mean, that's a very highly educated question, first of all. Um, because there is a taper in the shaft, it is difficult to even out the sanding.
Yeah,
Okay, you're absolutely right. And that's one of the things that we worked hard on, is to even out the sanding. Because we use, a few different types of mandrels for the for the different dots. And so it's hard to have sanding that concentrates on, let's say, the midpoint or the tip or whatever, because these mandrels, the different style mandrels, are also slightly different.
yeah.
So if I can make everything equal from tip to butt, then it's just uniform. But you're right, it is difficult to do because you have elevation changes and the sand, the shaft is going through the sander. I mean, there's a whole slew of things. You got the speed, you got the rotation, you got the grid, obviously, and then the taper changes are something that where you have to do some micro adjustments, and it's fascinating. It takes a long time,
Yeah.
but I think the results are very rewarding, I would say.
What is the what is kind of the time it takes to create a single shaft from material to cook to like the actual manufacturing time? I mean, I don't think most people can probably appreciate that without
Sure.
knowing what goes into it.
Right. So the actual manufacturing is pretty simple. So we have a big cat cutter. You know, the carbon fiber, we use exclusively Toray carbon fiber, Japanese technology. You know, I always tell people you can't be a great chef without great ingredients. And so we use, I believe, is the best ingredients in the world. So they come in these giant rolls and they weigh 250 pounds. And then we would take that, we would have a cat cutter that basically cuts our patterns. And so the patterns are always the same. 1,000 out of 1,000, the patterns are always the same, precisely cut. And then you would have these steel rods that we call a mandrel. You're rolling these various patterns. And we have some really cool trade secrets in that department, I think, which is what allows our shaft to feel very different. But then basically, in a nutshell, you would cut the patterns, you would roll that onto the steel mandrel, you would wrap that in cellophane,
Okay.
and then that goes into the oven. So the rolling process is quite quick. You know, I think we're doing about 200 shafts a day with our staff in St. Joe, and you know, it's just maybe a minute or so. You
Okay.
know, and it goes through a rolling machine, goes through a wrapping machine. That's also very quick. The cook time is, I would just say it's less than an hour. I was
Okay.
just, because the cook time kind of varies, but I would say it's less than an hour, right? It comes out, you take the tape off, and that's just a few seconds. You'll put that through a sander, and it's a, you know, we use automated sander like everybody else. So it's a two
Yeah.
stage, goes through two stages, then it goes into paint. The paint is probably the most time consuming. So paint for us is like a 4 day process.
Oh, wow.
So
Okay.
it's really, you know, the shaft is born in a morning. You know, a bunch of shafts
Yeah.
are born in the morning, and then it goes through the sanding and so forth, and then it goes into paint and the graphics, and that's where it kind of the journey slows down, if you will. You know, and then every step along the way we do QC. We actually QC every single shaft that we make, and that's something that we're very proud of. It's another reason why we manufacture in the US, so that we can make procedures that we're comfortable with, that we want to implement, and we know we're doing it, right? I'm not saying that I don't trust outside suppliers, but at the end of the day, I don't trust outside suppliers. So we do it ourselves. Every single shaft is QC'd, and that's one of the benefits of having your own plant, you know, own manufacturing facility.
Absolutely.
Yeah.
We were talking about the PGA show briefly. You were talking about designing a shaft specifically for long drive.
Hmm.
When you're coming up with these ideas, whether they're something you're going to give to somebody or work with somebody on, or whether it's just an idea you want to pursue yourself,
Hmm.
how do you do that? How do you get involved with manufacturing it in such a small batch way that it doesn't get in the way, obviously, of what you're trying to do with motion and fast motion,
Right.
the day-to-day work?
Yeah, again, excellent question because the plant is going. You know, the manufacturing facility, and I go there a lot. It's always running, right? People
Yeah.
show up at 8 o'clock and it's running until 4 o'clock. Okay. It's like running, running, running. So we have breaks for employees. We have lunch breaks, and then there's nights, and then there's mornings before they show up at 8 o'clock. So a lot of the experiments that we do, we would draw it up, you know, during the course of the day.
Mhm.
And then we would have it cut after the manufacturing is over. And then we would roll these things, whether it's before or during breaks or during lunch or after people depart. And so we are finding these little slots to do the development. That was the way it was for us for a long time. Now I'm in Camarillo, California, and I have turned my facility into exclusively R&D and fitting facility. And so now we have evolved to where we are rolling in Camarillo. So I have a rolling table. I have everything I need to make R&D, you know, protos in Camarillo. So then it becomes kind of a coordination between Camarillo and St. Joe. When I make one shaft, that's very different than making 200 shafts.
Right.
So there needs to be a little bit of translation between what we're doing and how it's coming out for us in Camarillo small batch versus production quantity in St. Joe. there's always things like that, but that's kind of how we do it, and it's quite an efficient way. We do it very systematically. I think the other big thing is testing. You have to test this stuff. And certainly I do not have the ability to swing at 150 miles an hour, right? And these long drive guys that I work with, they do swing it that fast. It's unbelievable, right? Like we're just talking about like the PGA Tour, and you say, oh, this guy's swinging at 120, this guy's maybe swinging at 125. Well, you go to that long drive world. Now you're talking 135, 145, 152, in
Yeah.
some of our cases. So I have to have somebody swing it. And so to me, a lot of the development is coming up with concepts, making different protos, and then really testing it. And that's a crucial part because I don't want to launch something and then having to change it a little bit later. I actually want to make a shaft that is going to live for 7 years.
Yeah.
So,
And then how does all that translate to the manufacturing process? Because obviously you're doing the R&D of the development of the shaft. You've
yes.
got something you want to make a run of or make part of your lineup permanently or make a permanent change to Newton. Then what has to be tested there in terms of getting it right to mass manufacture it as
Mhm.
opposed to one at a time?
Yeah, there's some micro adjustments that we do because we're certainly using different equipment between California and San Joe. And when I say different equipment, things like a press, they might be the same model, but I never assumed that two machines made by the same company, same model number, actually behaves identically. Like
Right.
I never assumed that. So you do have to to make some final small adjustments at the production level. But you know what? Once we've improved a lot of these processes, and we talked about sanding, but there are other processes that we've improved, it's made those transitions so much easier. So it's almost seamless. We can probably, make, any adjustments that, at the design level and then basically send it over and it'll come out after all the adjustments, it'll come out the way we want it to come out.
All
So,
right, the last couple of things with you.
mhm.
Have people been clamoring for iron shafts? Have anyone come to you and said, "Hey, I'd like to get into a Newton iron shaft"?
Yeah, I do get a lot of that. And same thing with hybrids.
Yeah,
Um, so for this year, we have the 2025 motion shaft, we have the fast motion, we have the motion LD, which you referred to the long drive shaft. Those are scheduled to come out. And then on the development side, we're always developing something, right? Whether it's on the gravity putter side or on the motion shaft side, we are constantly developing something. I mean, if this is the best job you can ever have if you're like a golf geek, right? And so definitely hybrids, irons, hopefully down the line. Um, I think one of the reasons our shaft business took up so quickly and so fast is because of the interchangeability of shafts with the adapter system.
yes,
Right?
yes,
And so that's fueled our business, and that's fueling now more fairway woods today. We sell a fair amount of fairway woods. Our fairway woods are manufactured as fairway woods. They're not driver shafts converted into fairway woods,
yep,
right? So they're different shafts. And so we're selling more of that now. And I think I'm seeing more and more hybrids with the adapter system.
yeah,
So we have started developing the hybrid shaft. And then it would follow that maybe iron sometime in the future, but irons are epoxied in. So it's a bit more of a commitment to change iron shafts,
yeah,
right? But I think if you went to a fitter to get an iron fitting, I think that would be a fantastic time to get fitted for irons. And I think so if we do go down the iron shaft, definitely start with working with fitters.
yeah.
I think we're over 300 locations around the country now, and we love working with fitters. And same thing with hybrid. I think we want to introduce that. The Champion Store guys, they've asked me about hybrid shafts. And all I can say is we're working on it. What I will tell you though, Ryan, is as you gain weight, right? So fairway wood shafts are heavier than driver shafts, right?
Yep. Yep.
Pound for pound, inch for inch. And then you have hybrids, they're heavier,
Yep.
right? And irons heavier than that,
Yep.
right? As we gain mass, shafts are easier to make because I have more material.
Sure.
Right? The hard one is a driver shaft. And for us, the hardest one that we're currently making is the fast motion that we are launching soon. So as we gain in weight, I know I can make some great shafts.
Yeah.
I know I can do it. I mean, I mean, personally, I play a lot of our protos, right?
Yeah.
And even like the hybrids, I play, shafts that we wrapped and, they're good. So I'm excited about that.
Last question for you, Aki. Is there anything right now? You talk about this being kind of the dream job for a golf geek. Is there anything that currently fascinates you or you're curious about that you're looking into and working on, whether it's for a mass production thing or not? Just something that's got your attention that makes you curious right now.
I think what I spend a lot of time on the field with players,
Yeah.
whether it's working with colleges or working with, tour players and whatnot. To me, what fascinates me is how your individual swing, right? How that results in a certain outcome. So I know that wasn't a very good explanation, but let me elaborate. So, on the Champions Tour, which is, I went to, 22 plus events last year. The swing speed is roughly 102 or let's say 100 miles an hour, and
Okay.
you're topping out at 115. That's the range, right?
Yeah.
That's the range. So that's only a 15-mile-an-hour difference. And normally on a 15-mile-an-hour swing speed difference, you would say, okay, that's either it's one of two dots or it's one of two flexes, right?
Yeah.
Because it's only a range of 15. I mean, and let's be a little bit liberal. Let's say it's a range of two shafts, two
Okay.
spins. Um, it really depends on the person's motion,
Yeah.
So I'm carrying a 4 dot through 6.5 dot on the Champions Tour. So that's 4, 5, 6, 6.5. That's four shafts to fit people that are swinging 100 to 115. Okay.
But you would
And
think it'd be half of that.
exactly, exactly. And that fascinates me. That's something I've always wanted to get better at, just understanding the mechanics. I always videotape a lot of different swings and try to understand why certain club delivery um, makes that person fit with one dot over another.
Yeah.
Okay. So that's super interesting to me. And I think, probably in the long run, um, we will be doing, somebody's going to come up with stick figures and, you take a video, somebody is going to turn into a stick figure, and then we're going to start approximating to better fit people. And I think, some of the bigger, fitters, will probably develop that so that they can have uniform fitting across all of their different locations.
Yeah.
Um, I'm definitely, going in that route as well. But there's also a side of me that like to believe that, um, there's still know-how. Like humans, I know machines are better than humans in so many things, but I like to believe, like in these things, that an experienced human can actually be amazing
Yeah.
relative to a machine, right?
Yeah.
And I think those are the things that interest me a lot. I think the other thing that interests me is feel. I think feel is obviously you have to have performance. I think we've got performance. I'm very gung-ho about our shafts. I'm very confident in our shafts. And I think they go great. They go straight, they go long, all that stuff. But then you bring in things like feel. How does it flex? How does the ball feel? The impact feel, so on and so
Yeah.
forth. Those are important consideration. That's above the spec, right? Because you can go to
Right.
any manufacturer and look at spec, but they don't talk about feel. There's no metrics for feel, right?
Yeah.
You don't say this feels on a 3.5 out of scale of 5, right? We don't have scale of feel. That's another thing that really interests me because I know that when I can make a shaft feel great throughout the swing and the impact feel is great, that's a huge advantage. And then same thing on the putter side. If I can have great feel stroking it, and if I get great ball feel, I know that that's going to go a long way, right? In addition
Yeah.
to the physics advantage of the product. So
Well, that both those things I think are fascinating, and they're probably worth their own podcasts themselves.
right.
Um, the long-term discussions about those things. So we'll have to have you back on and maybe deep dive into a couple of those subjects
Great.
next
We love
time.
that. Yeah.
But Aki Yorihiro, founder and CTO over at Newton Shafts at Newton Golf, thank you so much for spending some time with me. Really appreciate you being here on the Bag Room.
Thank you so much.